All right. Hello and welcome. My name is Carolyn Mooney, and I'm very excited to be hosting Goda Ramkumar today. She is an applied AI leader coming to us from Swiggy, and she is in the process of building and scaling a lot of highly complex and real-time decision systems. So I'm super excited to chat today.
Hey, Carolyn.
Awesome.
Lovely to be here.
Yeah, I'm really excited for the conversation. So first and foremost, maybe if you could tell us a little bit more about your background and your journey to your current role at Swiggy.
Hey, I think overall my journey with optimization starts right in college because operations research was one of my favorite subjects when I was doing my undergrad. So I just dived into airline industry at that point. That's where I think majority of decision systems and OR was being applied. After spending a decade there, then I moved to ground mobility
Okay.
at Ola, which is the Uber
Oh
of
yeah.
India, right?
Yep.
Um, and organically that transitioned into Swiggy. So some of my friends do joke about this that you're always working when something is moving from point A to point B, whether it's people on planes or people in cars or now anything because it's hyper local convenience,
Yep.
Swiggy. So yeah, it has been a very organic transition and all through just seeing more and more scale and impact through decision systems. Yes.
Yeah, I always joke that with people that, the process of decision making is either sequencing things or assigning things, and it could be people, machines, or services. It doesn't really matter, and I feel like that
Exactly.
always is a little funny for people because they're like, wait, but routing in a warehouse should be different than routing on a road, and you're like, well, there's similarities, you know.
They are variables.
Um,
Yeah.
yeah, exactly. Variables and the structure is somewhat the same. So maybe we can double click on that. So you mentioned a couple different types of systems, obviously, in your career and like in airlines and also at Ola. What do decision systems look like at Swiggy, and how have they maybe evolved during your time there? Because you've been there for a bit, and you've probably seen a bunch of changes and
Close
maybe
to
growth at
6 years.
Swiggy. Yeah.
Yeah, yeah. So it's close to 6 years. Of course, Swiggy started off as majorly a food delivery organization,
Yep.
and gradually it expanded to, quick commerce, dining out, basically everything convenience under the umbrella of convenience, right?
Yep.
So I've seen kind of the evolution where decision systems moved from very strategic decisions to very tactical and very real
Yep.
time decision. So strategic is something like when we were starting the quick commerce journey, the whole network design as to where should we position our dark stores is the
Yep.
problem to start with, which is very strategic. And till you actually do it, you don't know if you really made the optimal decision
Yep.
or not. Um, to more and more tactical with, let's say, how do we kind of place the orders at the warehouse to how do we move from the warehouses to the dark stores? How do we optimize the pick paths to the
Yep.
final real time of when the customer is placing the order? In that real time, how do we find the delivery partner who is going to deliver that order, right? Which is a
Yep.
very high scale, low latency decision. So
Yes.
it has a wide spectrum at Swiggy. But I've also seen one more evolution, which is things have moved from very offline to very online decision making, as
Okay.
well as I would say from very rule-based to heuristics to, more
Yep.
exact
Yeah.
or
No, that makes sense.
heuristic kind of optimization techniques. That's kind of the evolution that we have seen.
Yeah, that makes sense. Did you guys start with like one particular algorithm and then it kind of expand from there? Or like what did that group look like as it was kind of being built? Like I know for us at Grubhub, we kind of started with very much in almost the operational, right? The real time because it was so painful, right? As we were scaling, it was just impossible to have somebody manually like planning drivers to orders. Did you guys go through some of the same journey at Swiggy, and like how has the landscape changed for your team over time?
I think to be able to operate, I think getting that real-time assignment of the order to the delivery partner was the most bread and butter and heart
Yeah.
of this in some way, right? So that's where I think we started the optimization journey, right? And it started off in a very simple manner where we said, let's start with a greedy algorithm, first come
Yep.
first served kind of thing. That's how everybody starts. And you see it hitting the ceiling so quickly that as you scale, saying there is so much we are leaving out on the table, right? And
Yep.
gradually you move to okay, let's move some part of the decision to an exact optimization, like we built integer linear programming problem, but we couldn't do all the decisions. For example, we also pool the orders, like multiple
Okay.
orders can be delivered by the same executive. We said we cannot handle that scale. Let's pre-compute that part of the problem and just keep the assignment of a pooled order to a
Yep.
delivery partner to be left to the optimization. And then we said, oh, we are still leaving so much on the table. That pie only keeps increasing as you scale. And then we said we have to bring even the combinatorial part of that into our main, cron that's running, every
Yep.
minute. That's how I think we have seen that kind of change over
Yeah, so it's
time.
almost like expanded over time as you've gotten like new
Yes.
logic, or you're kind of I always kind of think about like that first decision kind of like grows legs, right? It has like
Right.
tendrils into other parts of the system, right? Because it's not operating as a separate entity.
Because the
Uh
the suboptimal pie only keeps getting bigger and bigger as you are scaling.
yeah, yeah. And affecting other systems, right, too. I think like that's always the interesting part. Like my systems engineering brain is always thinking about like, okay, here are all the boxes, right, that are connected throughout the architecture. No, but that makes a ton of sense. So it seems like you guys went through many phases and like kind of many sections of like, that model that you just described, right? Moving from like a greedy to a heuristic, right? To maybe partitioning, right, the orders right into pools, right? And then doing like assignment. How did you manage testing those decision models over time, or like what did that look like? Like, were you kind of conforming to some of software best practices, or kind of what were the things that you were thinking about with your team as you were kind of going through those phases?
I think as this was evolving, it's a learning journey, I would say, right? Because, of course, the beauty of these systems are it's not just that one run of optimization that you're running, it has a lot of second order effects as to the
Absolutely, yeah,
end outcome. One order affects the next, and so on. And you don't know at the end of the day what the impact is going to look like. So we did rely a lot on simulation before we
okay,
even launch something because there were multiple options to formulate. We also have a multi-objective optimization because we are a three-sided marketplace. There are certain objectives important for the customer, certain important for the platform, certain important for the
yep,
delivery partners, and so on. So it wouldn't have been possible without simulation to even take the right formulation out to production. So a lot of testing, I would say, happened in a simulation mode. In spite of that, um, we did realize there are gaps when you prototype something in a simulation to somebody codes it up for production. There is a gap, right? And
yeah,
uh, that gap leads to you finally going into experimentation and then realizing something is not working. So we did bring in some testing methodologies where we would say, let's compare the LP files themselves, right? Which
okay,
generating versus what the production system is generating. Just match them one to one to make sure at least the formulation you intended is what is going into the production, right?
yep,
But beyond that, once it goes live, even experimentation is very challenging because one day is very different from the other day. And to isolate and say what you changed is having the impact, it's very difficult. And
yep,
so we
like
do.
attributing effect, yeah,
Yes. So we do switchback testing of on and off so that we get enough, comparable set of, spatio-temporal sets that we
yep,
can come. But still, it was very challenging to even prove that the solution is working. So one part is the functional testing, which somehow cracked by matching the files, etc.
yep,
But whether what you saw in simulation is not happening in reality, that till
yep.
today is a learning exercise as to how do you crack that part.
Yeah, for sure, for sure. I worked on a lot of simulations in the past, both at Grubhub and also at Lockheed Martin prior to that. And I feel like there's a whole art and science, right, to building a simulator as well, right? Because you're simulating behavioral aspects, right? They're especially for systems like what you're talking about in mobility and commerce, right? Like you have a lot of people, like a lot of humans in that system, right? That you need to somehow represent like their choosing behavior, right? Or have policies, right, for them maybe accepting or rejecting orders or
Yeah.
changing things. So that makes a lot of sense. Maybe switching gears a little bit, how did you think about so the testing side? It sounded like there was a couple different ways that you were testing both offline with like a simulator and then moving things into more of a production environment with switchback testing, and maybe some other testing methodologies there. How did you think about building and supporting infrastructure for those systems? Like, was there a parallel software team, right, kind of working alongside your OR team, or like what did that structure look like?
So the structure currently is the data scientists in the team are the ones who are probably, very comfortable with, Python, for example,
Okay,
as their main programming language. So a lot of prototyping, and when you're still coming up with a solution, those experimentations happen, just on a Python-based simulation environment that they have. And there is a separate engineering team, which then whatever is the final solution you have come up with, they kind of re-engineer and redevelop that,
okay,
for production. We did uh, try once to make sure whatever we have in production, can we create a simulation environment just out of that, so that the gap between
yep,
simulation and reality reduces. We were not very successful in that part of the effort, but the development of the actual production optimizer system is done by the engineering team.
okay,
And once that's done, the a lot of experimentation and analysis that happens live is back to the data scientist to kind
okay,
of, evaluate, debug if something, is not working. Uh, but as we are scaling, I think from a infra perspective, I keep comparing this to a simple machine learning model life cycle, right?
yep,
So there's a data pipeline, a training pipeline, and then you
yep,
deploy. There is a clear workflow, right? For decision systems, somehow it has remained very bespoke and ad hoc in some way,
yep,
right? And one of the things we are trying to bring here is, like, for example, something like auto scaling. It's very easy when you have opened up an API or an ML model to just say to horizontally scale.
yep,
Whereas for a connected network optimization system, how do you exactly build something that can auto scale? So one of
yep,
the things we invested in is, can we build an adaptive dynamic scaling system that can break down the problem in real time based on the scale you're seeing, and can I, you
yep.
know, make my city into clusters that I
Into
can,
clusters or yeah, different zones, right? To be able to
and then
probably maintain solve
reconcile.
time, right? Like that's like basically
Yes.
the main concern. Yeah. Yeah, I think
Yes.
that's definitely a challenge that we've seen other spaces as well, and certainly what you're saying about ML pipelines and stuff, we hold that near and dear, right? Because that's what we work on at Nextmove here with decision ops, is trying to give some actually frameworks right into our space that look similar. Because I think you're right. I think for the most part, teams are a little bit in Wild West mode, right, and trying to almost build the plane while right while flying right? Those
Exactly.
algorithms. So it's a lot of work, right? It's a lot of work to kind of manage the infrastructure and also build the models themselves. And I think that can really slow things down, right? Like to your point, right, where there's like a lot of back and forth and things like that. So maybe what are some of the biggest, you've talked about a variety of different systems that you built at Swiggy, and kind of some of the phases. What do you think some of the biggest successes that you've had in building these systems, and like maybe what are some of the biggest challenges that you currently face?
Yeah. See, definitely the heart I spoke about, which is the main assignment of the orders to the
Yeah.
delivery partners, is one of the success stories in terms of every time we changed it, it delivered impact both on cost and customer experience, keeping the
Yep.
multi-objective pictures, like creating a win-win for all the sides. Apart from that, on quick commerce side, one of the very challenging problems which we are recently seeing a little bit of success in is the hyper-local, assortment
Okay.
planning, because to be able to really use the forecast at a small geohash, a set of geohashes, right?
Yep.
What do customers there want, and what do I stock where with my
Okay.
long list of thousands of
Of
SKUs that.
SKUs, right? Yeah.
So it's challenging both from scale perspective, just given the number of SKUs you handle, number of dark stores, number of warehouses, all the
Yep.
combinations. But at the same time, how do you actually get it right with where majority of them are very stochastic forecasts,
Yep.
a long tail where you may get an order or you may not, right?
Right.
So bringing these two concepts together and solving the hyperlocal assortment problem for quick commerce, I would say it was both challenging, interesting, and impactful in some
Yep.
way, is the way I would put it. Yeah.
Yeah, I think that's like a super interesting problem, right? Because some of your data can be so sparse too, right? In certain areas, and then you kind of have to have fallbacks for maybe combining areas, right? To make them a little bit larger and to have a little bit more impact. How do you think about like maybe like observing kind of like the output of that system? Are you kind of just tracking against the forecast and then kind of seeing kind of how close you were to that forecast? Or what are some of the ways that like you guys have thought about testing that system since it's relatively new? I'm assuming that's pretty much top of
Yeah.
mind.
Yeah. See, one of the things I think, which I would say an innovative way of handling this, which Instamart has done, is ultimately the customer needs to get the item. It does not matter which dark store around you is kind of delivering it to you, right? As long
That's
as
true. Yeah.
catchment area, we can even split the deliveries and deliver it to you, right?
Yep.
So that's one of the innovative things which helped us in this planning, because now you can plan it a coarser area and say, I need to place this item somewhere in this vicinity.
Yep.
It need not be at every combination of the dark store and the customer location level, right?
Yeah.
So that
Makes sense.
does really break down the problem. And of course, it brought in a lot of symmetry into the optimization that it doesn't.
Yeah. You're like, yeah,
So
don't
we
worry
did
about
do,
it.
we did do that innovative bit of breaking the symmetry part of it. Uh, but at a forecast level, we did have to break the SKUs into different categories. Some which where we have reliable forecasts,
That makes sense.
some where
Yeah.
we don't know. So it's okay to just stock a minimum amount
Yep.
there and don't rely on forecast too much as long as it's getting stocked somewhere, right? So
Yep.
so we did break the objective itself into SKUs where we know there is demand and you have to absolutely cater to it, versus those which you have to stock because you don't know when and where the demand will come from.
Yeah. No,
Categorizing did help us solve the
that makes
problem better.
sense. Yeah, trying kind of like making like the problem bigger in some ways, right? Like just bigger and smaller in some ways, right? By having the categories, you're making some of the data variables like smaller, but you're kind of looking at a broader scope, which can usually help on that front. No, that makes a ton of sense. I think that is like one of the challenges, especially with like stocking, right? Where you can have like SKUs that are super similar, right? Or kind of in the same category, and like how do you kind of handle that at that regional level. So maybe what are some, it sounds like this is a top priority, right, for you guys at Swiggy. What are some of the biggest like business outcomes or needs that are kind of driving your modeling today, and what's really top of mind as you're kind of looking across the mobility and commerce ecosystem? Like, do you see like commonality with like some things that you're hearing about in the industry at large, or kind of where do you think you guys are kind of breaking away?
I think any company which is into mobility or quick commerce will at all points of time have decision systems that need to work in a robust manner, right? I think right now, actually, top of mind is to ensure, because business priorities keep changing and it's a very dynamic market. So, how do we stitch together the business visibility and
Yep.
the decision systems that you're building to talk to each other in a very frequent and adaptable manner, right?
Okay.
That's one of the top of mind because there are multiple objectives and we want everything to happen. So how do you exactly, give an operating point for the business
Yep.
to work on, to say choose between these
Yeah,
two
like you can
operating
make the
points?
decision, right? Yeah. I think
Unless
it's
you
always
make it, the system will not be able to make it in some.
exactly, exactly. I think one of in our Decision Fest series in December, one of our guests was talking about like how business users, right, like kind of like hold the keys in a lot of ways, right, to the like profit and loss, but they're beholden to a lot of the automation, right? And so it's like an interesting dynamic, right? So I think what you're saying is something that we see too, is there's a lot of need to bring decision systems into a place that they can be collaborated on, and not
Yes,
just something that exists in the tech side of the house,
exactly.
right? Just
Building
with the
trust
algorithm
on the
engineers.
decision systems so
Yeah,
that there is a right.
yeah.
That's top of mind.
Yeah, for sure, for sure. I think that one is a very interesting problem too, right? Like you want to help people build intuition about how the decision model is working without getting too far into all of the specifics around an OR, right?
Psychology plus operations research together.
Exactly, exactly. You're like, do we want to really explain everything about this model?
Yeah.
No, that makes sense. And then maybe like in that process, like how are you thinking about the team going forward? How are you thinking about like agility and decision science, building trust with those with business users? Like what does that look like as you head into 2026?
Because I do want to move to a world where, scientists, first of all, can deploy decision systems end to end, just like they do ML models, right?
Yep.
So that you have that end-to-end ownership, you have complete transparency and visibility, so that you can debug and fix things
Yeah.
as they come. And definitely building that level of transparency and visibility into decision systems on the business side. So we do enable this via, for example, via a few Google Sheets, via a
Yep.
few documents, etc. But a more systematic way of doing that so that decision systems become just part of the language for
Yep.
business, and you have a level of configurability and control on the decision system so that you feel that it's my system and I own it, and
Yeah,
I
yeah, some ownership or agency, right, in that system. I think
systems that
that
can
that's
give
huge.
make that happen. This is the way I would like to take it
Yeah. Oh,
in
that's
a direction.
awesome. Well, any final thoughts that you want to leave people with about the mobility and commerce space? Maybe some lessons learned or some things that you wish you knew?
Overall, I would say anybody who is working on decision systems for mobility or commerce, two fundamental principles are: one, you're a multi-sided, like a
Yep.
marketplace, right? So you need to always think win-win for all the sides of the
Yeah.
business, which are always working with multi-objective problems, right? So
Yep.
there is no simple solution
No simple
out.
solution. Yeah.
And second, any system you build needs to go hand in hand with the business goals and with the business outcomes. So rather than thinking of it as a tech system, it should be a tech system bridging, uh, you
Yep.
know, the business folks driving it is the way I would like to see the systems as a principle. Yes.
Yeah. No, I love that sentiment. And I also have loved having you here on our talk today. So this has been a delight. It was really fun to hear kind of all about the systems at Swiggy. And yeah, until next time.
Yeah. Love this conversation. So thank you for having me here.